because of air pollution. Let's be honest, people are selfish. The only thing that we need is have convenience in our everyday life. So what I'm trying to understand is if in a given area, it should be better to get people to use more bikes, and if they use more bikes, what infrastructure should it have? It should be bike lanes, it should be bike servicing. Should we invest on zip cars so they can commute with their neighborhoods all together? And it's a very complicated issue. But the good news is that from Europe, the experience suggests that there are feasible ways to go to that direction and reduce our cars so people can spend less wasted time on congested highways. Thank you.
One way to reduce our dependency on cars is to call up NASA or Elon Musk and ask them to commercialize rockets. And we could just use rockets to go from work to school or the doctor. But first, we might need to understand how this technology works. So Shujaut is here to explain to us how rockets work. So please join me in welcoming him to the stage.
Thank you. Can everyone hear me?
Yes.
Okay, so how do rockets work? So when we hear the word rocket, only one thing comes to our mind. A 200,000-pound complex machine with more than 20,000 moving parts, and which puts humans and satellites into space. So that really overwhelms us, and we think that we might have to know something about rocket science to really understand the first principle. But it's not rocket science. So it's as simple as trying to comprehend the phrase, whatever you push, pushes you back. So in fact, when we were kids, everybody among us did a basic experiment, though unknowingly, which explains how do rockets work. And let's do it now again. So I have this inflated balloon in my hand. So we all can imagine that the air present inside the balloon is at a higher pressure because it's compressed. So rockets work in the same way, but we don't have compressed air inside the rockets. Instead, we have a mixture of fuel and air. When we burn that mixture, a large quantity of gases is expelled. And then we compress those gases using some pumps, and then finally exit them through the nozzle. So let's do this experiment, see what happens. I'm sorry. Let me do it again. Very good. So that was a test rocket. So what actually happens here is that the force is being exerted on the expelled air when it leaves the balloon or your rocket. So as we know that nature loves to conserve every physical quantity in every situation, and nature loves symmetry. When balloon exerts a force on the expelling gas, the expelling gas does something in return to the balloon. So to conserve the motion, the quantity of motion, what we call linear momentum in engineering. So to conserve that momentum, the expelling gas is pushed back on the balloon. And the force with which the balloon pushes on the gases is equal and opposite to the force with which the gases push on a balloon. So that force gives rise, that force is the basic principle which really propels your rocket forward. So it happens everywhere. Like while you are sitting on your chair, the force with which you are applying, the weight force by which you are applying on the chair is exactly equivalent to the force which the chair is applying back on you. If it doesn't happen that way, then I think the chair will collapse. So this is the basic. It's called Newton's third law. It was named after one of the greatest physicists of all time, called Sir Isaac Newton. So to every action, there's equal and opposite reaction. So the action is expelling gases. The reaction is what they do back to the rocket or balloon. Thank you.
So if we're all going to start having rockets in our garages, then we may actually want to use them to go to space sometimes. So what if you want to go to Burger King, pick up something, and take it with you? Well, you might want to understand how your food changes when it actually enters space. That way the Whopper that you left with is the Whopper that you have when you're on your journey. So here to help us understand how food changes during space flight, please welcome to the stage, Will.
Can you hear me okay? Yeah. All right, excellent. Thanks for the welcome to Destiny. Hello everyone. My name is Will, like Destiny said, and today I want to share how my work on vitamin degradation kinetics can benefit interplanetary spaceflight. For those who are unfamiliar with vitamin degradation kinetics, it is simply the rate at which vitamin loss occurs in foods. Like us humans, vitamins have a finite lifespan, and they tend to degrade over time. And with our models, we can predict the amount of vitamin remaining during processing and storage. And for our processing model, we can determine the best temperature profile that can maximize the vitamin concentration while ensuring the necessary food safety is met. And for processing, we utilize a thing called a retort, which is essentially a huge pressure cooker designed for commercial sterilization of jars, pouches, trays, and cans. And to give you a better understanding of how our model works, say if we took a food product and we cooked it in our retort, and we measure its temperature profile throughout the cooking process, and immediately freeze it post-cooking, and analyze it for our target compound pre and post-cooking, we can use these parameters to predict the vitamin concentration. We can use these parameters to determine the best temperature profile to minimize the vitamin loss during processing, which is pretty unique. And now that we cooked and sterilized our product, we can now use our storage model. And with our storage model, we can predict the vitamin concentration at any given time point. For example, if I wanted to know how much vitamin C is in our food product 3 years from now, then our model can theoretically predict that vitamin concentration in that food product. So in summary, I forgot to bring my props. I was going to bring a retort pouch and a freeze dry pouch to give you an idea of what I'm talking about, but I'll just use my body. So say if we had like Earth, so Earth is like my left hand, and then we have Mars. So everything on Earth, here, that's where we utilize our processing model, and this basically allows us to figure out the best processing technique to minimize the vitamin loss while ensuring the necessary food safety is met. However, to be able to get to Mars, it requires a period of time, and during that process, we can utilize our storage model, and this can theoretically predict the vitamin concentration at any point during that storage during the flight. So overall, this information can be utilized to make sure astronauts are in optimal health during a long-term space flight. And that concludes my talk. Thank you all.
So, if you've ever left your food in the car too long, it might have gotten a little bit rotten. But if you've decided to eat it anyway, then your stomach might be bubbling and it might be a bad situation for you in your bathroom. Well, so we want to understand how we can reduce the effects of this effect and also improve our stomach health. So with her talk on the anti-inflammatory effect of orange peel extracts, please welcome me.
Can everyone hear me? Good. Can you imagine that in your jet tract, there lives huge amount of bacteria? The number is more than your whole body cells.
they just live like organ in your body. But if the balance disrupt, they may promote incidence of inflammatory bowel disease. Inflammatory bowel disease is a chronic disease. No drug can cure it so far. No drug. But just in America, 1.6 million people are living with inflammatory bowel disease. Sadly, the number is still increasing. As a food scientist, we want to help people to promote the gut health with food method. Look at this orange, it may help. Our lab has proved that the orange peel extract could help to promote the gut health because it can inhibit the inflammation in cells before. And now we want to go further to confirm if it can still work in vivo. And what's the relationship between the gut microbiota and the inflammation? We use mice to do the experiment. We found that the orange peel extract could reduce the inflammation level in mice significantly, and no toxic effect was found in healthy mice. Also, the bacteria in the gut is changed in both healthy and unhealthy mice. Surprisingly, we found that some bacteria can indicate the level of inflammation in mice. Therefore, we can conclude that the orange peel extract could inhibit the inflammation in mice. And also, the effect of the orange peel extract is associated with the gut microbiota changes. So the take-home message is that if you want to promote your gut health to stay away from the inflammation bowel disease, don't forget our orange peel extract. In the future, we want to apply orange peel extract to people's diet to help you promote your gut health. Thank you.
So, everyone talks about DNA, but what about his poor forgotten friend, RNA? Well, today is the day that RNA gets its spotlight. So with her talk on co-transcriptional folding of RNA, please welcome Elvan.
Can everyone hear me or is this too far? You all heard of DNA, right? It is the recipe for life. And RNA is the messenger that carries this recipe in order to make proteins. And proteins are the building blocks of life. They determine what happens in a cell. And what if I told you that RNA, the messenger, could dictate whether a protein can be made or not only by changing its structure? Let me explain how. Imagine we're inside a bacterial cell, and this here is a small molecule. I have this silly string box here, and imagine this is the protein that makes the RNA. If this protein makes RNA really fast, the result is such a complex structure that it didn't have time to cover the ligand. So I couldn't dictate which part of the RNA could be read. So the message could not be read. Proteins may not be made. Let's think about this enzyme. This enzyme can make the RNA really slow. It makes the RNA in such a way that the protein is covered, the ligand is covered, and only a portion of it is open, and it can be read to make proteins. And what does this do? This can dictate what proteins will be functioning in the cell. So RNA, if I can control this structure formation, if I can determine which part of this ligand will be covered, which part will be open to be read, I can dictate which proteins will be functional in the cell. And this is exactly where RNA-based therapies can be really improved and go to the next stage and help us formulate drugs and vaccines that can help with genetic disorders, even cancer and HIV. Thank you.
So, in the USA, there's a big problem with obesity. Maybe not in Massachusetts, but in the rest of the USA, just trust me, they actually have this problem. So, there are some creatures that can actually help us understand obesity better. Worms. So with her talk on using worms to tell us about obesity, please welcome Yiren.
Anyone hear me? Okay. Obesity is a big problem, right? It is not only annoying but also dangerous. Why annoying? Because it may ruin your figure. And why it's dangerous? Because it may harm your health by inducing many chronic diseases such as diabetes and hypertension. So, as a food science PhD student, my research aimed to screen out the food bioactives for the potential anti-obesity therapies. The animal model I'm using is called C. elegans. It's a free-living worm found in soil, and actually it has very small size. The adult worm is only 1 millimeter, and you cannot see it unless you use a microscope. In the lab maintenance, it can be cultured on the agar plate with a non-pathogenic E. coli as a food source. So here comes the question, why? Why using C. elegans, small worms? I'm going to give you 3 reasons. The first is cheap. Compare with rodent animals like mice or rats. One C. elegans string only costs you $7. Moreover, it can be freezed for long-term storage and thawed to recover if you need to use them. Which means that you only need to spend less than $10 and you can keep it forever. The second reason is short life cycle. At room temperature, right now like 25 degrees C, only 2 days are required for the small newborn C. elegans baby to grow into an adult worm. And the longevity of C. elegans is approximately 21 days. Therefore, it significantly shortens the experimental period and makes C. elegans a great model for the high throughput drug screening. Third, and the most important, is the conserved genetic pathways. It was found that the obesity-related lipid metabolism pathways are highly conserved from human to nematode, the C. elegans. So the compound that works on C. elegans has high potential, can be applied on human. And the underlying mechanism that determined by using C. elegans model could provide important information for the research of human anti-obesity therapies. So take this home. Small worms can be big heroes. Thank you.
So, if I came into the audience and randomly picked somebody out and told you that you had to come on stage and give a 3-minute talk, you might get a little bit nervous. Well, you might want to know that there's more than just a little bit of butterflies floating around in your stomach. But what exactly is in there? Well, to tell us more about why we get nervous, here's Atreyi.
Good afternoon, ladies and gentlemen. And I forgot to open up my mic. Good afternoon, ladies and gentlemen. Are you able to hear me? Okay, so, well, I'm here right now and I already have butterflies in my stomach, but I'm going to tell you more what's going on rather than just saying that line over and over again. You must have had this feeling once in your lifetime, maybe right before you had to give this interview, or give this huge presentation the next morning, or you just saw your crush walk right past by you, or just anticipating your first kiss from the person you're really emotionally attached to. But the problem here is, there are no butterflies in your stomach. It's just pain and anxiety. And the last time I checked, pain and anxiety is just pain and anxiety. It's not love at first sight. Now, researchers and other technologies have actually shown that there's a huge correlation between the amount of fatty acids you consume and the anger and sadness and hunger in your body. And that's why you grab onto that refrigerator door so hard when you're sad, and then you finish all of that ice cream, and in the end you realize you just screwed up your routine one more time. Now, the big point here is there's a lot of chemical reactions going on in your body when you realize you have those butterflies. Well, they are not butterflies, but they are a huge amount of contractions in your gut. Now, let me break this down to you. Suppose A is the manufacturer of candy. Sorry, I don't have the props, I don't have candy. But A is the manufacturer of candy. B is the person who's going to package that candy and send it to C, who owns the store, and C will send it to D, who wants to buy the candy. The same thing happens in your body. Your brain realizes you're going through a period of stress and therefore wants to release the hormones of epinephrine and non-epinephrine. And therefore the hippocampus tells the hypothalamus that, hey, you've got to do something about this. And the hypothalamus releases the CRH hormone to the pituitary. Pituitary takes that hormone to the adrenal cortex, and the adrenal cortex starts releasing the hormone of epinephrine or non-epinephrine. Basically, the fight or the flight mode. Now, my main question to you is, do you actually want to flee the scene when you see your crush? Or do you want to punch him in the face? Because I don't think you want to fight him either. So the next time you actually see your crush walk right past by you, do understand, it's not trampolining gut bacteria, it's not partying parasites. They're just a huge amount of contractions and your body's becoming disbalanced because of the hormones raging through it. Thank you.
So far we've heard 12 contestants tell us about a bunch of different STEM topics. And you guys have made it all the way to the end, where we have the last presenter who's going to tell you how you can use mathematical models to understand all the scientific topics that we've just heard. So please join me in welcoming to the stage Abhishek.